to this computer. Yes, I did.
Okay. Now I see it recording. When I left the meeting, it said converting the recording, and I assume the recording has stopped. So I will stay online, but I will mute myself and my video,
Okay,
everything, and until the class ends. But I will
no
not
problem.
be in the meeting, okay? All
No
right.
problem. I guess it's recorded in both the cloud and my personal computer. But anyway, when we finish the meeting, I will know it.
Okay.
Yeah, thank you, Dr. Kirkich.
Okay.
It should not be a big deal here.
Okay. Okay.
Okay, so here we have probability. I don't have to. B times probability A times probability A plus probability of B over probability A bar times probability A bar. Oh, sorry. So this is one application of the law of probability, total probability theorem. So I hope everybody gonna be, I hope everybody knows what is that, because I assume everybody has, the background in basic probability. In general, sorry, let me close this. In general, it should be like this way. So the denominator here, this part. And because here we can have, the classification of the EIs. And the important thing is here, we need to have they are mutually exclusive, and the union of them is the total space. So this is the thing. For example, like here, if I had make the classification to be A and A bar, so of course A, union A bar is everything, and the A and A bar mutually exclusive. So this is the thing. Okay, so let's see how can we use this Bayes formula to detect or calculate this problem. So here, to make a simple calculation, we need more conditions. So now let's assume that we have 1 million paragraph in the database, and suppose 10,000, which is 1% of them, are classified to be sensitive. Now suppose we are interested in the word bomb, and among these 10,000 sensitive paragraphs, let's say 3,000, which is 30,000, wait 1 minute. Yes, among these 10,000 sensitive paragraphs, so which is already 1% of the total 1 million, 3,000 of them include bomb. Whereas among the non-sensitive paragraphs, which are 1980, 0.2% of them include the word bomb. So one part is sensitive, right? Sensitive total is 1%, and the other part is non-sensitive. So sensitive 1%, that means 99% are non-sensitive. And now among these sensitive means given 1% of this sensitive, 30% include this bomb, are really, something very, very dangerous, so that we need to have a look at this. And then in the other 99% non-sensitive paragraphs, 0.2 of them include this word bomb. So we can use the total probability theorem, which which was just introduced to calculate the probability of bomb. So here I can say probability bomb equal to probability bomb given sensitive and non-sensitive. Remember the formula here, A. So here B means bomb. A means, or I can write S. S means sensitive. And the S bar means non-sensitive. You see what I mean? So it will be exactly the same here. So I know among those sensitive paragraphs, bomb appeared in 30% of them. So 30% times sensitive, total sensitive is what? 1%. 1%. Plus, among these non-sensitive things, a bomb appears in 0.2% of these paragraphs. So it's 0.2 times 99%. And then you can calculate the number, the final answer is 0.498%. And now I can use the Bayes formula. How to use the Bayes formula? Here we go. We have a bomb given sensitive times probability sensitive. So probability of bomb given sensitive 0.3%, 0.3, which is 30%. The probability of sensitive is 1% divided by probability bomb, which was just calculated here, which is 0.00498, and you will get a probability here. In other words, here we get the probability that uh, a bomb shows and the paragraph is sensitive, this probability is 60.2%. So this is the calculation. Okay, now I have the interested word, the probability of sensitive given the interested word bomb appears. But remember, here we said we're interested in four words: job, make, crowd, bomb. Four words. Okay, so now we have calculated this one, bomb. We're gonna do the same thing. We're gonna do the same thing to calculate the next word, which are job, make, crowd. Here to save some time, let's ignore, ignore the detailed data, but we will use exactly the same method to calculate all of them. Now, suppose I've already calculated, which is S means sensitive, B means bomb. So probability one is what we just calculated. Given bomb appears, the paragraph is sensitive. This probability is this, 0.62, 0.602. Let's say P2 is the paragraph sensitive given the word make appears. Suppose the probability is 0.85. Well, make is a very, very popular word, make different things, make it occur, make it, So it doesn't mean, to see a make it doesn't mean it's sensitive because many, many normal sentences also include make. Suppose this probability is 0.85, and then suppose given the word job appears in the paragraph and the paragraph sensitive is 40%, and finally suppose given crowded appears in the paragraph and paragraph sensitive is 0.5. So now we have 1, 2, 3, 4, all these four probabilities. So how to estimate the probability that the paragraph include all of these four words is indeed sensitive. How they do it? So totally there are only two cases, right? The paragraph is either sensitive or not sensitive. So here we're gonna use the definition of the of the probability. So we're interested in the probability that it is sensitive. So the numerator gonna be the sensitive probability, which is P1, P2, P3, P4. Means what? Means all of these four things occur. And the denominator is the summation of two cases. Case number one, sensitive. Case number two, non-sensitive. So sensitive is itself. Non-sensitive is what means this one is the bar. This one is also bar. Bar means the opposite, which means 1 minus 0.602. This is 1 minus 0.85, and 1 minus P3 and 1 minus P4. And then you're going to calculate the probability is 85.1%. You know what? This is really, really a very big number. This shows, hey, if a paragraph include all of these four words, sensitive. Sorry, the four words are. Let me make this are bomb, make, job, and crowd. If in a paragraph all of these four words appear, then the chance that it is a sensitive paragraph is 85.1%. Isn't it a very good result? It's pretty smart actually. Of course, in the real application, you will consider let's say in LLM, you will consider many different things. It's not that easy. You will consider different token and then you will insert some let's say a word here and then you will use a neural network. But in this very simple introductory example, I would just introduce the Bayes formula here, which is actually already a very good result. And in real application, we typically have a predefined threshold constant alpha. So the paragraph will be classified to be sensitive if this probability paragraph sensitive is greater than or equal to alpha. So for example, if my alpha is 80%, then here my calculated probability is 85%. It's bigger than 80%, then I claim this paragraph is sensitive. Or if my alpha is 90%, then it's not sensitive. So this is a super simple application of the machine learning here. And similar idea, we can detect and the filter spam emails. And here is a very simple example. Some a little mathematics, but as long as you know basically how it works, then it's okay. I mean, you don't have to really. I know many people are scared of the mathematics. Unfortunately, I do believe if you really want to learn AI, you'd better read some basic math because otherwise it will be very difficult for you to just try method A, method B, method C. You see what I mean? Because if you don't know the mechanism behind it, it will be pretty difficult for a pure, really, really pure application because you don't know how everything works inside. Okay, so sorry. So here, this is the first example. Now let's have a look at the second example. It's a hand return digit recognition. So we can write those words and then we can have the AI to tell us, hey, what is this word? So for example, here we can have zeros, one till nine. And I believe later we will use scikit-learn, which is simple and pretty efficient, fast, small and fast Python library to run those codes. And that includes 1864 or 1832 something examples there. Basically, they're just collecting different people's handwriting, hope not too bad, and use those handwritings to do to recognize those the next or a future a target handwriting. Here it's a supervised learning. Why? Because I will give the computer a label. So for example, here I can have, let me see in Zoom, oh, here I can write. For example, I tell computer all these numbers are zero, these numbers are one, these numbers are two. I realize my handwriting is better, right? So, and here are three. In other words, for each of these columns, I will tell you, sorry, I will tell Python or tell the machine that, hey, these training data are associated with the label zero. These are associated with the label one. And then we can actually just, let me remove this. We can actually, based on these, to train the data. And the details I will introduce, I believe, in KNN, if I remember correctly, when we introduce KNN, I will show a simple example here. But basically, we will just, make put every one of them of the handwriting, split it into different pixels, and in each pixel, for example, we can use 0, 1 to indicate whether a point is black or white. White means nothing. Black means yes, a point is a pixel's filled here or a cell's filled here, and then use this and vectorize the data, and hence our visualize the data gonna be a matrix, be a vector, and then to use some method to organize the vectors, then we can do the machine learning to detect what is this number. And even in neural networks, the same, but the difference that we'll do different layers and based on the layers to provide you a more accurate prediction. But the basic idea is we're gonna, be based on those handwriting given labels and then train for futures. So later, for example, I can write something. Let me on purpose write something weird. Let's say I write it like this way. Then you will need to tell me, hey, whether this is a one or seven, because it looks like you can say it looks like this way, it's clearly a seven. But if I write something like that, you know what I mean? It could be difficult. This even for a human, it's sometimes difficult, and that's why many people write seven like this way. So it will be more clear. But we do need to teach machine how to recognize this. Okay, so this is the second example, introductory example. And example three is here. It's a more general case of the classification. So like here in example one, we need to ask, hey, based on the training data, I'm going to give you a new paragraph, which for example includes these four words. I'm going to ask you whether it's sensitive or not. So it is basically a classification problem, means I will ask you to give a label to a new paragraph. Let's say, or a new sentence. Let's say this is a sentence, make a bomb and drop it to the crowd. Let's say I give you this sentence, and I'm going to ask you, hey, is this sensitive? This is, I want you to make a prediction. In other words, I want you to give a label, yes or no, whether it's sensitive or not to this sentence. And similar thing here, in this example, handwriting, I'm going to ask you, let's say, suppose I write a number, I write it like this. I'm going to ask you, hey, what is this number? Of course, we human can directly say this is two. But for machine, there are 10 possibilities, right? I'm going to ask you, is this a zero or a one or a two, blah, 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 or nine? So it's also a classification problem, but the difference is that here we have 10 classes, 0 to 9, instead of here, 2 classes, sensitive or not sensitive. So in general, classification means for given training data, I will train the things, and this training data will be labeled data. In other words, for example, here, all this training data, the label is 0. All this training data, the label is 1. And then I will give you a new data, and I ask you to predict its label. So this is called classification problem. So for example, these two are relatively simple ones. These are more difficult. Let's say, hey, I will give you a picture. I'm going to ask you, hey, is it a cat or a dog? For example, here, this is clearly a cat. This is a dog. So what I'm going to do is that I will give you, for example, let's say 10,000 pictures of cats. Be careful here, these 10,000 pictures, they do have labels. I will tell the computer, hey, each of these 10,000 pictures, the label is cat. And then, for example, I can give you another, let's say 9,000 pictures of dog. And then, of course, they also have the label dog. Then I'm going to give you 2 pictures. Let's say I give you this. By the way, these 2 are my cats. I will give you the picture of this. I'm going to ask you, hey, what are these? I hope they can recognize this is a cat and not some monster. Anyway, people may say, hey, it's so easy, right? I mean, is it really difficult? Let me show you something online, because before I thought it was easy as well until I see those pictures, cat or dog, classification, and here we go. I guess some pictures were generated by machines, not real pictures, because I remember I've seen some pictures, they look real like a dog. So those pictures are cat pictures, and then let me see, those pictures are dog pictures for training. Here it uses neural network. For example, here like 1, 2, 3, 4, 4 layers. I mean the middle layer, 1, 2, 3, 3 layers, and then I would detect different things. I can say cat looks dog classification. Wait 1 minute. Like this one, it's already not that easy. Sorry, because I remember I've seen some pictures online, which it's even for human, it's very difficult to. No, they don't show it anymore. Before I've seen something, and then this is a very traditional classification problem. And the corresponding higher level class of this is called supervised learning, which is learning with the teacher. So basically, classification problem is one of the supervised learning problem. It also have something, for example, like regression problem, which is another super classic problem in supervised learning, and we'll include both these 2 problems in this class. And again, the target is to find the correct prediction of a given unlabeled sample based on training data. The training data are with the sample, are with the labels. And another class of the learning is called unsupervised learning, which is to learn without a teacher. So what's the difference? The difference is that it only includes the input in the training data without observation or without a label. So for example, go back to the cat and the dog example. Here, for example, I will give you 6 training pictures. Each picture is a training data, because we will vectorize all the for each training picture, we will vectorize it. And then we can see, for example, this is a cat, dog, cat, cat. Yes, this is a cat, dog, dog, like this. So this is in the training data telling that in each picture the label, what label it is. However, if it's an unsupervised learning problem, I'm not going to tell you, you know what, this picture is different from this picture. This is called a dog. This is called a cat. No, I'm not going to tell you. I will just give you a picture of A, give you a picture of B, and then you want to find the pattern by yourself. You want to detect that this is, let's say, animal 1. This is animal 2. These 2 things are different. People may immediately say, "Oh my goodness, it is so difficult, right?" And yes, of course, in general, unsupervised learning is way more difficult than supervised learning. Then why should we, let's say, consider the unsupervised learning? Why not, for example, for each picture, I have the label already done. Isn't it simple? The truth is that those unsupervised learning are typically used in something called pattern recognition, which is even our human beings, we don't know the pattern. For example, let's say in financial area, Bitcoin. So let me just, for example, look here. So here we see the historical data, let's say 5 years, historical data of Bitcoins. And then I give you the data and I'm going to ask you, hey, what's going to be the data tomorrow? Or what's going to be the Bitcoin data next month? Will it increase or decrease? It's very, very important for me to make a prediction, right? Because if I can predict correctly, then I will be a billionaire, like Warren Buffett, right? Of course, nobody can really do it so accurately. So this is something because we do not know the pattern. I try to find out a pattern that, in terms of the chart, that it works. So if I, for example, I see a specific pattern that I've already researched before, then I'm going to say, hey, look at this. I have ABC pattern, and hence the chance that it's going to increase is, for example, 70%, for example. So I'm going to buy. Or let's say the chance of a dipping is, let's say, 80%, so I'm going to short sell. So these are the pattern recognitions. So that's why in the real world, somewhat unsupervised learning is more important, but it's of course is also much more difficult in general. And in this course, we will give a very brief covering of the unsupervised learning. Okay, another very, very big classification of the machine learning is called reinforcement learning. Due to the time limit of this class, I don't have time to give a reinforcement learning. But basically, reinforcement learning is something, first of all, it's like unsupervised learning. No label is needed for the training data. And we will make a decision on each like time order the data, let's say time equal to 0, 1, 2, 3, 4, blah, 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 blah. And then each of the decision, it will trigger reward or a punishment, which is just a function. Let's say reward is a positive value, punishment is a negative value. So the machine will learn adaptively from the delayed feedback to try to maximize the reward. So of course, I don't want, I will try to, kind of like get as many rewards as I want, and I will try my best to avoid those punishment. This is more like actually like a Markov decision process. If you're familiar with this, it's actually a dynamic programming problem. Here we can see some examples here. Let's say this is a robot. This is a robot walking experiment. So basically, I will try to, so let's say 40 years ago, maybe you don't believe that engineers and the scientists, they really manually write a code to make the robot, to guarantee the robot will not fall. Is it good? Of course it's good. The problem is that it will be very, very sensitive, meaning that, let's say the robot shape is now like this way. But suppose I add something, let's say I add a head, something here, and I put a left hand, like this, and then the gravity point of the machine, of the robot will be changed. Before the gravity point can be here, now by adding the head and the hand and the arm, the gravity point can be here. You see what I mean? And then again, for any small changes, you will need to rewrite all your codes. And the code could be, I don't know, millions of lines, and then consider how much time it will take you to do so. Then by machine learning, or let's say specifically here is reinforcement learning, we don't have to do so. What we can do is, for example, we can install a sensor somewhere, and then if the sensor is unbalanced, which is, for example, the height of that as touch the ground is very low, then I will trigger somewhat, for example, like a punishment. And then we will try to, given the setup of those parameters, let the robot just walk. And then I can try to balance or try to set up those parameters, try to maximize the working time of the machine. And hence, this is somewhat like a reinforcement learning problem. Those parameters will be automatically tuned like adaptively, and we will run a Markov decision process, use the dynamic programming, and then we'll get everything. This is actually it deserves like 2 semesters of the course at least. It's a pretty reinforcement learning nowadays combined with deep learning called DRL, deep reinforcement learning. It's a pretty hot area. Unfortunately, due to our time limit, we cannot cover it. If you're interested, you can just watch the YouTube videos. It won't be covered in this basic level courses. And finally is the realization. Well, all those theories looks good, but how would you really perform it? We're gonna use Python because basically, even if for those kind of simple image recognition, we cannot like just by hand for each pixel because each picture can include thousands of pixels, and then if we have millions of training data, it's gonna kill us. So we'll use computer and we basically use Python. Why to use Python? Why don't we use other languages? Because in Python there are already a lot of existing libraries that we don't have to rewrite everything by ourselves. That's why we use Python. And in this class, we'll try to use Anaconda platform. It's easier. Before I used the PyCharm, and I found it's many students don't like it because you have to install it locally in your local computer. It's somewhat like troublesome nowadays. So we all like apps. So I will try to only use Anaconda in this semester in this course. Any questions about lecture one, the basic concepts? It's just a very basic concepts. Any questions? No? Okay. Now let's start lecture two. Lecture two is about Python tutorial. So if you're already very familiar with Python, to be honest, you can skip lecture two because again here I do not require the Python experience. As many participants in this AI certificate program may or may not have coding experience. So for lecture two, I will just introduce some very basic things for Python, and I will show the real code. First of all, yes, any questions? Uh, yes, I see you raise your hand. Could you please unmute yourself and directly talk because it's very inconvenient for me uh, to let me see. How can I see the messages? I even don't know how to see the messages. You can unmute
Yeah.
yourself and talk.
Oh, okay. I just want to confirm, like, we can, do we have to use Anaconda or we can just use like, I'm very familiar with Colab. I use Colab for coding or,
It doesn't matter,
oh,
but you do need to use Python.
oh yeah, yeah, I use Python and or
Yes,
Jupyter.
well, that's a very good point. The answer, to be honest, is both yes and no. First of all, you will see Anaconda is probably one of the easiest thing. It's super simple. The reason, yes, I mean, technically, you can use whatever you want. The problem is that I don't have that. And if you use that to code, I'm not sure how can I check your exams and also homework. So I would highly recommend you use Anaconda. Trust me, it's extremely simple. As long as you know how to write a Python code, I honestly cannot think of anything more difficult than that.
Okay. All right. So I would have to like install that. Okay,
You
no
don't need
problem.
to install it at all. That's something I will introduce. Just give me several more minutes. I was surprised to see it as well, to be honest, because when I write code for like my own projects, I typically use PyCharm. And this time in this semester, when I try to use Anaconda, and I found that Anaconda already has the app, which is pure online. Can you believe it? Which is right here. I mean, I will introduce it. Just give me about 10 more minutes. I will let you
Okay.
see everything, which is
Thank
extremely
you.
simple. You no longer need to analyze it. You no longer need to install it anymore. Trust me, it's extremely simple. You will love it. Okay, so here is a link for fun, which is the most popular coding languages. Let me just click it. Let me just close all these things. Uh, oh, it's 2024, not 2025. I believe 2025 is something similar. And SQL is number one, seriously. Well, okay, so here's a rank. I personally don't agree with SQL to be listed as number one. I personally would believe Java and Python are number one and number two. Then JavaScript, script, and C pound. I don't know how people read it. I personally call it C pound. This is very important to write different things, or if you want to write those kind of mobile apps, you will use this. C++, R, C, those kind of things not to say. I don't know what is Perl, but Go is a relatively new thing. Let me see. Do I have 2025 most popular? Oh no, oh, come on. Code language, coding language. Here we go. Java. Where's Python? No, ignore it. I don't believe this is correct. I'm shocked it doesn't include a Python here. Do they have something like here? Let me see. Okay, actually, I love this. This is actually more, a more classified, ordered those things. And you can see, but nowadays Python is really, really advantage or really, really popular. JavaScript number one, number two is Python because really Python is almost everywhere. And regarding here, it shows the front end. And you may not believe that there are some platforms you can even use Python just one thing to perform both front end and the back end of website development. Myself, I've never tried, but I've seen this online. It's pretty, interesting. Okay, so and another, or I would say the most important thing for a data analyst to use Python is that it's a very, very, simple. And there are many existing libraries. So you can directly just import that library and you can use directly. You don't have to, start from the beginning and write everything. Like JavaScript, something I really hate, especially if you have experience in writing those kind of codes, like for example, Google Sheets or something. Almost everything you have to rewrite. Of course, you can find some code and copy and paste, but it's just really not that convenient. And there are some applications of Python, but basically it's almost everywhere. Okay, here we've already mentioned why it's Python because libraries. And about this Python tutorial, which is this lecture two. So it's a tutorial for beginners. It includes some core concepts, not only for machine learning application, but really some in general things. And no prior experiences required. And again, we will use Anaconda platform, specifically Jupyter Notebook, to write and run Python codes in this class. Okay, first of all, let's go back to the student's question, Tohib. It's a very good question. So before, let me just quit everything, start from beginning. Assuming that you don't know what is Anaconda. So Anaconda is just it was basically a computer, but it was basically a company, but now it's very, very big. So you can just search Anaconda online and then just click anaconda.com. Before, what we did was I even deleted. So before, you will need to install something called Anaconda Navigator, I believe. That's how we did it all before. Now you don't have to do it anymore because I just realized that they already have the app, which is an online environment, so you can have this. If you have never registered, you need to just sign in, register something. Let me tell you a trick. If you have a edu this kind of email, you may want to use your your education, university, or whatever email to sign in because you will have it's something like let me sign in. Let me sign in, and then it's here upgrade. So they try to charge me like $50, I believe, to make it to be another level. I'm not sure how to find a starter business. No, starter. There was something kind of like they have different packages and called let's say price. Here we go. So 15 or $50 per month if your academic account, which is you signing with your edu email, you automatically get this. Many other things are not important. The most important thing is here. I realize it's not enough for the time. So here the CPU time is only 1,000. Where it is. I forgot details here. There's something there's something about the time. It's right here. It's right here. If I click, there's a time. I believe if you use a free version, it's only 1,000 seconds for the CPU to run. Honestly, it's a very short. Like I was preparing the class, I use up almost all the time, and I have to use. You see here, Like I already use 1,000, 340 over 1,000. It's not the time you spend on it, but the time it's CPU usage in the server. By this one, you will have 8,000, if I remember correctly, of the CPU usage, which should be complete enough. Typically, it can support you to code for, I don't know, maybe 10 plus hours, which should be enough. Okay, so once you log in, you will see this one, this page. So we will click this one, the Jupyter Notebooks. Let me just close it. I just click it, and then it takes some time. Make sure your internet is good, because otherwise you again need to install the Anaconda Navigator environment, which I hate, to be honest. That's the reason why I don't want to use the PyCharm in this class this year again. So here is the thing. So here, because I already created something here. So for yours, if you have never used it, it should be empty here. So I can, for example, just create a folder. Let me see how to create a folder. New folder. You can say whatever and then you click it and you can create new documents. But here it's just an example. Let me just delete it. Delete. Okay, delete. So I create something called in class. So now I'm gonna show the codes of lecture 2. I'm gonna put a lecture 2 Python tutorial. Okay. It stops me from use a column, so I can use lecture 2 underline Python tutorial. Okay, here we go. So now the thing is that here I can just have create a new notebook, and then here you can just rename. Let's say I call it lecture 2. Okay, here we go. So now I have the wait a minute, what is that? Sorry, Zoom just gave me a warning info here. So weird. Anyway, let me just ignore it. So okay, here is the cells. Okay, here I'm going to introduce the things. Okay, now let's introduce how to use the Jupyter Notebook. So launcher, you can just close it. Here you can write whatever you like, for example, print 3 plus 3, and then you can run it. So each of these is called a cell, and then you can add or delete different cells. I will introduce in detail how to do it, but each of them is a cell. In each cell, you can write different codes. Let's say A equal to 3, and then B equal to A plus 1, and then print B. So that's what we say B equal to 4, something like that. So each of them is a cell, and anytime we can modify and rerun a cell. So this actually gives you a very, very convenient way to like debug, rewrite, modify different codes. While in other those kind of like IDEs, it's gonna be not that convenient. You will have to run it again, again, again. Instead of just visually, you can see so many codes simultaneously. So this is one thing. And another thing is that here you don't have to install. Like before in the Anaconda Navigator, you need to install a lot of things, locally in your local computer, which is pretty troublesome. But here, just as long as you have quick, internet, then that's it. And then let's see, how can we make it further? So first of all, the Jupyter Notebook has two modes. They're edit mode and a command mode. So the edit mode by name, it's just, like here, I can add it, I can write whatever, whatever thing you want. This is edit mode. Command mode is if you're in the edit mode, you press escape, ESC. You see here, it becomes, you see here, I can write whatever I think, right? And you can see here the cell is, you see the frame of the cell. It is, let me use this zoom again. Okay, you see the frame here, it's like in blue color, but once here I press escape, the keyboard escapes. And then you're gonna see it shows like a gray color. So this is the command mode. And then in the command mode, I'm gonna perform those kind of cell level actions. For example, I can run the code, I can insert new cells or deleting new cells, something like that. And the switch is super simple. You can just use enter, or for me, I'm lazy. I just use the mouse to click it. For example, here I want to edit this cell. I want to edit this cell. That's it. And then escape. That means the command mode. Okay, now let's see some shortcuts. Basically, you want to make it faster. So yeah. Okay, so you can keyboard shortcuts, or if you're a lazy man like me, just Control Shift and H. Here are those kind of the shortcuts for the command mode. There are many things. To be honest, many of them you will never use. At least I've never used many of them. Here I summarize something that I typically use. The most important thing is first Control plus Enter, which will run the selected cells. So for example here, like here, I'm gonna run. I press Shift and then Control, and then it runs and tells you this too. Regarding the meaning of this node array, we'll have details about those super basic commands in this lecture later. But you press Control or Shift, it means you're gonna run the code. The next one is A. A means insert a new code, insert a new cell above the current cell. Say here, I'm in this cell, and you can see the cell number is 3. So I press Escape. It's in the command mode, and I press A. See it? Insert a new one. Insert, insert, insert. So A is insert above. B is insert below. So similar things. Say, suppose I'm here, I press Escape, then I put B, B, B. You see? It's inserting below it. And now I have so many cells, I don't like it. I want to delete. How to delete it? I select one cell and press D for twice. The key D for twice. So let's say I'm here, I select this one, Escape, DD, DD, DD. You see? The number of cells are decreasing because I'm deleting them. Similar, DD, 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 DD. Okay. Don't delete this one. Okay. So, and the next one is a tab, which is to show methods, something. You will see later. Later when we write functions or use some different methods, you will see how I can use tab to save my time. Again, I mean, that is just based on the assumption that you're a lazy person. If you're not lazy, you can just type one by one, But for me, I'm always using the table keyboard, the key. Okay, and the next one, sorry. The next thing is show line numbers. It's not necessary, but for me, I always want to use it, especially if I'm giving a class, a lecture, because this can show the line number. So you can simply just here. For me, again, I use the shortcut, which is Shift plus L. If you don't use the Shift plus L, I forgot where it is. It's probably View. Yes, here. Show line numbers. Then it will show. We can say, okay, in line 2, here line 3, and also here it has a cell number, cell 3, cell, let's say whatever it is. Oh, you need to run. Let's say print, la la la, and then it will give you a cell number, which is cell 4, something like that. Okay, then the next page is something called Markdown. So if you observe carefully, here we're all in the code mode. But here I can have a markdown. Let's say, first of all, I will insert a cell before it, above it, how to insert above. In the command mode, put A. See it? Okay, so I change this one to be markdown. I can have, let's say, lecture 2 on, let's say today is May 20th, 2025, and then I'll run it. By the way, run again is Shift plus Enter. See, I will have lecture 2 on this. And now I can add another cell below it, which is in the command mode, press B. Then I can write from poll. I can use 2 pounds, which is the first layer of the heading. So here I have 1 pound is the head. Or you can say the zeros, which is the biggest. Here I can say, for example, introduction to, let's say, Jupyter Notebook, and then run it. Oh, sorry, I need to change to markdown. So here run it, and here run it. You see, this is smaller. And you can go up to, I believe, 6 levels. So here I showed only 4 levels of subheading, major title, major heading, subheading, a 4th subheading. I guess you can have up to 6. Let me try. I'm just curious. 1, 2, 3, 4, 5, 6. Let me see, how does it look like? Oh, it's so small. It's very baby, just So indeed, you can play like this. And then another thing is like string to make the bold and italic. This is the same as Google chatting. I don't know whether you use like a Google Chat, but in Google Chat this is exactly the same. Let's play with that. Let me just I can close it properly. Make another one below it, and then let me make something like, for example, I can make First of all, change it to Markdown and then make it to be, let's say bold text. Sorry. And then I can make it to be, for example, italic text. And then let's run it. Again, run is shift and enter. See, bold text, italic text. We can do this and we can just make it 2 lines, something like that. And the more interesting thing, I don't know how many of you use the LaTeX or the text language. I can use those kind of things to write, a text language. For example, I can say, let's say, sum of squares. I can have, let's say, I can say, for example, 1 I equal to 1, 2, and I square. So this means 1 square plus 2 square plus 3 square plus until I square equals to fraction. This is n times n plus 1 times 2n plus 1. I hope everybody knows how to derive it, but it's pretty simple. But so we can write those kind of things as well. So that's the reason why it's called a Jupyter Notebooks. It's basically a notebook, but it's pretty powerful. So these are the things you want to use maybe in your homework. Why? Because because you can write it to be like this problem. Let's say you can make it like this way. Let me just add one. Let's say homework 1, and then here's the example problem 1. You see what I mean? So that you can just run it and then mark down, run it, and then here gonna be your code. Let's say print, let's say 3, and then okay. Then next one will be I use 2 pounds problem 2, and then mark and then run, mark down and then run that. Problem 2, blah, 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 and then problem 3, problem 4. You can do something like that. So this is markdown basically is just to make the notebook more organized, and we will use it in class as well. Okay, so I believe after it, these are just to let you know, get familiar with the environment of the Jupyter Notebook here. If you have not had an account, you may want to, just apply for an account right after the class. If you have the edu email, it's the best. But even if you don't have, I would say, unless you really code it crazily, otherwise, I mean, it should be enough because every 24 hours it will give you 1,000 seconds. So, okay, now let's start with our formal decoding part. So the very first thing I want to teach is the print function, as we have already used. It's actually super direct. It's just a print. Let me start from here. So I can just print whatever I want. Let's say hello world. This is always the very first, and then shift and enter. Hello world. And then for the quotation, you can use single or double quotation. It's not a big deal. We can say hello world and double quotation. Oops, sorry. They're the same thing. The difference between single and the double quotation is you sometimes you may include a single or double quotation inside, and hence you can only use the other one. Let's see here. Let's say print. I want to say I am learning Python, and I am is this. I'm learning Python. And if you run it, if you run it, you will see an error. See? Undetermined string. Why? Because you already have this, already have a pair of the single quotations here. So Python doesn't understand. And hence in this case, if you really want to type this sentence, which is I am running Python, you must use double quotation here. So in this way, Python knows, oh, okay, this single quotation is just something inside, which is I am. So here we go. So it will show you I am learning Python. You see what I mean? And the similar things. Suppose I want to print, let's say, what did I use? I'm learning Python, and then I'm a course. Let's say I'm gonna say it's a course intro. Let's say just intro to machine learning ML. And then you see the course name intro to machine learning itself already has double quotation. So we cannot use double quotation here again, and it will show the same error because it doesn't understand. It shows already there's a pair of the double quotation. it will be something, kind of like misunderstanding. And hence here, I'd better use a single quotation. So this is the same. Here we go. So this is how we make this, and done. Super simple, right? For the print function. The next one we want to introduce is the input function. So for the input function, it is just to get some input info from a user. So here I can use, for example, input. Let's say, what is your name? Okay, so when I put a shift and enter, or if you want, you can use this, but can click it, but it's pretty slow. I just shift and enter, it will ask you, hey, what's your name? I can put, for example, my name is Yiwen Xu, and then and it will tell you Yiwen Xu. Later, when we know the variable, I can actually write like this way, a equal to this, and I can just print a. Let's say ABC, whatever, DDD, it doesn't matter. And then you see A is this. But anyway, in the next slide or which one, I will introduce the variable and you will see it. So we have seen print, which is to like showing output, and also the input function, which is to get an input. Now the next one will show, is it a variable? Yes, the next one shows is the numerical variables and comments. These two are also very, very popular used here. So for example, here I can write something, for example, like a equal to 1, b equal to 2 times 1.1. So if here let's say print a, b, so you can see still a is 1, b is 2 times 1.1, which is, of course, 2.2. Okay, now I can make it c equal to, this is exponential. So this double multiplication is exponential. So this is this is equivalent to 2 to the power of 3, which is 8. So this is the thing. And sometimes if I write a code, the logic could be confusing, or sometimes, just to debug a code, I will write something like this. This is the prompt. And then you can write whatever I want here. This is called comment. Different languages comments are different, like JavaScript. I always use this, and sometimes please excuse me if sometimes I have some habit because I actually write a lot of JavaScript code, something here. Sometimes it's just when you use different languages, it's just very easy to get something wrong. So for the comment, what is the point for a comment? The point of comment is, the first thing is to explain. So for example, I can say this is equivalent to 2 to the power of 3 equal to 8, which is this. Or sometimes maybe I want to debug a code, say, hey, why should I write 2 to the power of 3? What if it's 2 to the power of 4? Maybe I want to, later we'll see it. I mean, in this class, I may want to debug a code, a line of a code or something, so that I can write it this way. So this is a comment. And in case you need to write a lot of comments, you can use this. And then you can write whatever you want inside, and all of them will be commented. So once Python reads like a pound here, anything after it will be ignored. Ignored means it won't execute anything here, because this is to let human read and not let Python read. Similar things here. As long as Python sees this structure, which is a 3 quotation, single quotation, and another 3 single quotation, anything between them will be ignored by Python. This is again for us, for human, for the coder to read. So these are the comments, and we can see more different more of those operators and or variables. And then let's say here, I have d equals to 8/3. So 8/3 equals to this number. So this is d. And the next one will be integer dividend, which is, let me see, this. So we all know 8 divided by 3 is 2.6667. But this means divide by 3 and get the integer. So this number will be 2. This 0.33666 will be ignored. The final result will be 2. Be very, very careful that this integer division operator always pushes the number towards 0. So for example, 8 divided by 3 is 2.66 something. Then I have two choices. Is this a 2 or 3? Because I will push the answer to get close to 0. And hence 2 is positive. Push to 0, that means floor function. Floor function meaning that if it's 2 point something, I will get 2 instead of 3. However, if I write it to be negative 8 divided by 3, it will be negative. Well, 1 minute. Uh, I realize something's wrong. Wait 1 minute. Give me one second. I believe, did I include something here? It's not. Sorry, my fault. I should say this. I should say this is more like a floor function, meaning that it will push to the integer closest to it, but smaller than that. So that, for example, I can write a negative 8 divided by 3 equal to 2.667. And so the integer division gets a number less than or equal to this, but closest. But less than or equal to this and closest. Gets an integer, I should say. An integer. And hence you can see, sorry, I forgot the negative. I need to find out an integer which is less than or equal to this number, but closest to this number. What's the answer? Negative 3. Similar thing, if I use positive 8 divided by 3, then what is the answer? It's 2, right? Because you need to find something which is smaller than or equal to this number, an integer which is smaller than or equal to this number, but closest. And this is actually the same as a floor function. And the final thing is a reminder, I guess. Let me see. The final thing is a reminder. Module operator, which is, let's say, 8, percentage of 3, which is, the remainder of 8 divided by 3. And which, one minute. Yes. And here is, we will have a press print with the 2. Or if I say 9, which will be 0 because, 9 divided by 3 equal to 3. There's no reminder. So these are the operators that I want to mention here. And then the next page is something about, here we can just define a variable. And here we can just make a variables operations. So for example, here, just very simple, x equal to 2, and then y equal to 3. By the way, it doesn't matter. You can have spaces or you don't have spaces here. It doesn't matter. However, the indentation before it does matter. Later when we introduce functions, I will tell you why. The z equal to x times y, let's say, and then print x, y, z. So you can see this. Be careful, it's case sensitive. So for example, if you write like this way, it will tell you wrong because x is not defined. The big X and the small x are different, 2 different variables. Be careful about this. And the second thing, we can write something from x equal to, let's say, x plus 1, and then I can say y plus equal to 1. So this is equivalent to y equal to y plus 1. And then can print, let's say, x and y. And see, first of all, I define x equal to 2, y equal to 3. Now I have x equal to x plus 1. So x equal to 2 plus 1, which is 3. So now here, x equal to 3. How about y? Y plus equal 1. That means y equal to y plus 1. So y should be equal to 4. Here, y equal to 4. That's the thing. You can do something similar. Let's say y minus equal to 1. That means y, if we write like this, let me just write in another one. Minus and equal to 2. This is equivalent to y equal to y minus 2. And you can print y again. So here we already have y equal to 4. So y equal to 1 minus 2. So y should be equal to 2. So here we go. This y equal to 2. So these are something basic, which are super direct and simple. Any questions here? No. Okay, good. The next thing is the fprint or printf. So printf actually provides you something that in the print you can print both variables and those kind of like context, those kind of text, making it easier and enhance the readability of the output. For example, here I can write, let's say, still we'll have the similar thing. Let's say y x equal to 2, y equal to 3, and then let's say z equal to x times y. Now I can write print f, which is, let's say, x is x. So for a variable, you need to put them in the big bracket. Y is y, z is z. That will show you x is 2, y is 3, z is 6. So that's the thing. Okay. Any questions? No? Okay. Uh, so these are things about numerical variables and comments. And also the print function basic applications of this. The next one will be string variables. So numerical variables are something we just mentioned. The values are numerical, while string variables means the values are string. So for example, here I can have a name equal to, let's say, Tom. By the way, Tom is my nickname, so I can use printf again. Print my name is name. So this name is the variable, this variable. My name is name. So it will show my name is Tom. And then remember, we have the input function. So I can make this to be an input. I can say name equal to input. What is your name? So, and then I will pass the answer to this variable called name. This is string variable, I should say, called name. And then I can print this is name. So it will ask you, hey, what's your name? Say, suppose I said, my name is John Smith, and then it will show this is John Smith. So you can put whatever name you want, okay? So this is the input function with the string variables. And of course, we can make a string variables, do some basic operations as well. For example, I can have first name equal to, let's say, input. What is your first name? Last name equal to input. What's your last name? And then I'm gonna have the full name equals to first name plus last name. Oh, by the way, I forgot, I'm way too fast. So here you see the power of the table key. So when I put the LAS, I put the table key, on the keyboard, which is next to Q. You press it, you see it, it directly give you the hint, last name, and then press it again. That's it. If I have many different things, then you will need to choose. But this will really accelerate your coding. Let's say last down like this. I don't have to type the whole thing. Because if my variable is very, very long, then it will take me a lot of time to finish it. So full name equal to first name plus last name. Guess what's gonna be? Print full name, okay, and then run it. What's your first name? Let's say John. What's your last name? Let's say Smith. And sorry. You see the point here? Because first name plus last name, so it's just John Smith. I want to add a space here. How to do it? Simple. Add, put a space. Don't forget, this is space, okay? And do the same thing. Let's say Ewan Shu. First name, last name, Ewan Shu. That's it. So these plus show the operations of the string variables. And you know what? Not only plus, in even the multiplication works here. Let's say suppose I have let me see here. I believe string. Yeah. Suppose I have string equal to, let's say, AB. Now I have string. Let's say repeat. Let me use this notation. Repeat equal to string times 2. Then print string repeat. You see here, I press table. So it gives me two selections. So for example, I can choose this one and press enter. String repeat, and also I can put, let's say, string times 3. And there's going to be big strings AB. So string times 2 is AB, AB. String times 3 is AB, AB, AB. Don't make a mistake like this way, then it will be wrong. because it doesn't have explanation. It's not a numerical variable. So this is the same. Okay, so we have already introduced the let me see, numerical variables. We have introduced the string variables. The next one will be Boolean variables, which is basically true or false. It must be one of them, either true or false. Okay, I can define something simple like this. So is student equals to true. And then I can say is, let's say, grad student equal to false. And then I can just print is grad student. Let me see, which one did I use first? I used is student first. Is student, is grad student, true, false. Be very, and you see the color. Be very careful here. You must write the first letter capital TRUE, true. You cannot write this way. And you see the color changes? Because if I write this TRU, this true, is like Python preserved variable, or let's say preserved, I should say constant somewhat here. It shows the Boolean. But if you're writing this way, then it's completely wrong. You see what I mean? Let's say suppose I false. So this means I as a student is a student equal to a variable called a small true. But the problem is that I've never defined this small true true variable. So if I run it, it will show error. Why? Because this variable true, small true is not defined. The similar thing, the small lowercase variable false is never defined. Mistake. Name true is not defined. That's the thing. Be very, very careful. In Python, it's very sensitive for the capitals, case sensitive. Be careful about this. Okay. And the Boolean variable will be super, super important in, in what? Oh, sorry, I'm a mistake. This one should be here, and this is the result here. This one should be here. Will be very important in something like if statement or loop structures. Later in this lecture, probably not today, probably next class or next class, you will see it. Okay. So the next example is here. Oh, I use the statement in. So the next example would be, let's say, suppose I define string equal to I love Python, and then I have is Python equal to, I can write it this way, Python in string. Did you see something here? This in is in green color again. This means, again, this in is already preserved by Python. It's a built-in function. So I'm not sure. I don't think I can say it like a function operator. I should say it's a built-in operator, so that I cannot use it by myself. Don't write, for example, like this. Okay, it's all wrong. It must be the all lowercase in. And then I can write, for example, is, let's say, Python in string. And now I can also write, for example, is like in string. So this in means, so this sentence means, is Python the whole string in this variable? And yes, it is, because I can see a Python here. So now I can just print all of them. Let's say, again, I use print here. Be careful, because here I already use a single quotation. So here I need to use a double quotation. Python is in let me use this one. String. String means I love Python. Is this correct or not? Then I'm gonna write this. It's Python. And then use /n means I want to, leave one space here to make my life easy. I'm just copy and paste. And then I can say Python. This small Python is in a string. Is it correct? And then I'm gonna have the small Python, and then similar things. Here is like, and here's is like. But here, because the end, I don't need it. So here we go. First of all, this shows Python is in out of Python true. Why? Because it is, this variable is Python. The meaning for me to show these two is to let you know it's case sensitive because this Python, you see, I love Python, this Python here, but it doesn't have a small Python, a small p Python here. And hence, this is Python in string. This is false. This is true. This is, of course, false because I don't have a word like in this string. So it's this. And this /n is this. You can see there's an empty line here. There's an empty line here. So this is the how we write the codes here. Any questions here? Be careful that the word. Be careful that it is very important here that if I write something like this in, this will automatically return a Boolean value. It won't tell you, like in some other languages, it's going to be 0 or 1. But here will be Boolean. Be very, very careful. I realize that's correct. Sorry, because code, wait a minute. Code. I should actually remove this heading. And then code is here, output is here, explanations are here. So I just remove this heading, it will be correct. I will revise it after this class. The next one is the index or indices of a string variable. So for example, I have a similar thing, which is I'm learning Python, string equal to I am. To make my life easier, I'm gonna write I am instead of this, okay? Because this quotation problems. I assume you've already be familiar with that. I'm learning Python, and then I can write string. Let's say I'll name it to be string 0. It's string 0, and then I can write as a string 2 equal to string 2. What does it mean? Print string 0 and string 2, and then this is a variable, right? Which is a string variable called str. Okay, so str0 means the 0th index. Pay attention that in Python, all indices start from 0 instead of 1. So this I is the 0th index. The first index is a space. The second index is a, and the third index is n, and you can just continue it. And here, string 0, that means I'm asking what is the 0th index. I should say, what is the 0th index of this str? What is that? It is I. The first is what? It's space. And then string 2, which is the second index, is a. So that the result is I and a. Okay? So this is the index. And let me show you more things like the column negative things. Let me use the same thing here. Let me make my life easier. Let's say string 3 equals to, let's say, 0 to 7. Did I use 7? Yes. And then string 4 is, let's say, -1. And then let me just run this. Okay. Wait. Oh, okay, great. And why? Let me print it in 2 lines. Okay, to make it easier. So this use column, that means I'm gonna get the range of it from 0 up to this number, but not include this number. In other words, it is actually asking from 0th index to the 6th index. Let's count it. 0, 1, 2, 3, 4, 5, 6. So this will be I blank M blank LE. This will be the result. You see it? Be very, very careful. 0 column 7 doesn't mean from 0 to 7, okay? It actually means from 0 to 6. Be very careful. Here, -1 means the last one. How about -2? -2 will be this one. So -1 indeed is n. If I don't like it, I say -2. It's going to be O. See it? Which is this one. So this is pretty special from Python. I don't think any other languages need it, have it. Any other languages, you will need, for example, length of, let's say, string -1, something like that. But anyway, let's forget about it. I have not introduced the length function yet. Okay, so these are the things. Again, be careful. This means from index A up to, but not including index B. In other words, it is from A to B -1. Be careful. And negative means I count from the back instead of from the front, okay? Okay, and the last one is something similar to this structure, but without the numbers. So similar things. I'm learning Python. Let's say 5, 6, I'll remember how. So let's say I just have column. This means all the whole string. Let's say the whole string. And then if I write from whole, I don't have, see here, it is where I just removed. Before I have 0 to 7. Now suppose I just have this 7. This is actually the same as string 0 to 7. So if I do not write the number before, that means all. If I do not write the number before and after, that means, before is all, after is all, means the entire string. Okay, now the next one will be similar, which is if I just write a number before, okay, 3. So this means from index 3 to the end. Let's print them. 5, 6, and then print string 7. So wait, what is wrong? There's no T. So here we go. First of all, string 5 is everything, which I'm learning Python. Number 6 is from the beginning to 7. Again, nothing means all. Then from 0, 0, 1, 2, 3, 4, 5, 6, yes, 6. Again, be careful. When it shows these two 7, that means the end of 6 is 7 minus 1, not 7, okay? And the last one is the 3 till this. And that means from the third index to the end, 0, 1, 2, 3. So it starts from end to the end. So it's end learning Python. That's the thing. Okay, these are all the operators of the string variables that I mean, those kind of inside index operators that I want to introduce here. And then the next one is the length function, which is, for example, again, I am learning Python. I just use the same thing and just delete it. And then I can print length of string 20. It is just the length, but be careful when I'm saying length, that is really how long it is. Like this, the length is 1. This, the length is 2. You see what I mean? You don't need to say, hey, this length is 0. Okay, index and the length are two different things. And let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And indeed, it's 20. To make it easier, you can say, let's say string 2 equals to, let's say, la space. It should be 3. Print string 2, length of string 2. So you can see this is 3 here. The space is counted as one length as well. Okay, be careful about this. Okay, and the next one I want to introduce is the find method. So the find method is to find the index of the first occurrence of the given character C. It will return -1 if the character is not find. And here, py, oh my goodness. Okay, so here I have, for example, my string is, let's say, pi, uh, Python. Okay, now I have, for example, print string dot, remember, find, and then find what? Let's say here, I'm gonna find the pyt first, pyt. 7. What does it mean? So we have a pyt here, right? But actually, you see what? We have another pyt here. We'll have two pyts. But as we mentioned, it will go to the first occurrence of the given character C. And hence, it's going to be here. And what is this index? Let's just count it. 0, 1, 2, 3, 4, 5, 6, 7. And this is the answer, 7. Be careful. This is the entire structure. We cannot say, for example, here's a py. No, there's no t, so it's not counted. It starts from here. Okay, then what if, let's say, I want to have something, let's say x. I know I don't have x, right? What should it return? Should return to -1. See it here? If return 1, if it's not found. Here we go, okay? So this is the result. And the next one, we will use, we will find these four, how many? 1, 2, 3, 4, 5, 6 methods. Upper, lower, title, is upper, is lower, is title. And by definition, it's actually dot upper method is to convert everything to be the uppercase, lower is a lowercase, title is title case. Title case means the first letter of each word is capital and all others are lower cases. Is upper, is lower, is a Boolean variable, which is a Boolean method, not a Boolean variable. It's a method to return a Boolean variable, which you check if all characters in the string are uppercase or are lowercase or are the title things. And then we can just do this machine learning. Okay. Let's say we have course equal to machine, let's say learning. And then I'm gonna, let's say course upper equal to course dot upper. Course lower, or spelled wrong, course lower equal to course dot lower, and then course title equal to course dot title. Okay, now I can just simply print the course upper. Oh, that's why. Print course lower, print course title. Why? Sorry. Here's lower. Okay. Then here we go. And you can see here I put it in this way on purpose. And you can see here, all capital and all lower cases and the title cases. Okay. And similar thing, we can use, something like is lower, is upper, is title. And then, okay. Then to save time, I'm going to print like this way and then print, let's say course upper dot is upper. Course upper dot is lower. And then I can have course upper dot is title. Eh? True, false. Oh, sorry, I forgot the parentheses. And you can see, of course, course upper is what? Course upper is this one. This one is upper. This one is not lower. This one is not title. Similar things, I can make it all true. Let's say course lower is lower, I believe is capital L is, and also make course title is title, and it should be true. Here we go, true. Okay, so and what's the point of to make it? Because in many cases, if you want to add it to the text or get an input or something, let's say you handle the passcode or something, this one can really help you to do something. Later we'll show you the example, something like I want to input a name. For some people, the habit is to put a name, have formal John Smith. A formal John Smith should be like this, John Smith, right? But some people would like to, for example, put some, spaces between the name or after a name. And sometimes, I can write, for example, John or small. It's not kind of like all like formal. Then use this method, I can make it to be formal title, make it to be formal, and then later we'll show something like strip method, which is to remove those kind of the spaces from the beginning and the end. So I will make it kind of like standardized. That's the reason why we use those kind of methods for string variables. Okay. Oh, sorry. And the next one would be split. Split is to split. Split is to split something to list. And I know you may get unfamiliar with list. We'll introduce later after several pages here, list. But here, let's temporarily accept it, the list. So I will have something different. I use a space. Okay, I like Python. Let me have, for example, like the strings, string 1 equal to, let's say, I like Python. String 2 is equal to the pound. I like Python. string 3 is the comma, I like Python. And now let's see how do you make a string? 1 split equals to string 1 dot split. Split, not split one. Split. And then here is by what do you want to split? I put a space here. That means I'm gonna split string 1 by space. Okay, now if I print string 1 split, see it? It separate or split I like Python by the space. And I split this one string to be 3 parts, to be actually 3 strings, and I save it to this list. Or you can consider, let's say, this bracket. I save it to this bracket. Later you will see, you will know this is actually called list. So this is the thing. What's the application? For example, first, last name, or something like you fill the forms. This split function can split many different things. And in split, the most commonly used is split by comma or split by the space. And so I can do the same thing. String 2 split equal to string 2 dot split. And I can, let's say, use this one, pound, to split string 3 split equal to string 3 dot split. And then here I can buy comma. And then I can simply just, let's say, I can just print string 2 split, string 3 split. And here we go. You see what I mean? So here it's, split by pound, here split by comma. And this is a list as something you're gonna see later, that I can use something similar as, like I can write, for example, string 1 split, let's say 0. This 0 means the first element, which is I. So I can print, it should be I. See, I. And then if I put 1, that means the first element. Be careful, this is the zeros, okay? The index starts from 0, not from 1. So this is the first, which should be like. So make it easier, list is something like a container. In the list, you can put it like a number. You can put strings or even boolean. It doesn't matter. It's just a container. Okay, here we go. So these are the things of the split function. Any questions? No? Okay. Then the next one would be strip. Strip is actually to remove something from the beginning and the end. So I can have, let's see, I like Python. Okay. Similar things, I like Python. String equal to I like, but due to whatever reason, I'm pretty careless. I put a lot of spaces here. So I can use strip to remove this. I can have print, let's say, string dot strip. And then you're gonna like strip based on what? Based on space. So I put a space here. Be careful, here's space. Here we go. I love Python. See it? It removes all the spaces before, from the beginning and the end of this string variable. And similar things, I don't have to, remove by space. I can remove by, for example, the pounds. And then here, I make it 2 pounds. Similar things. I like Python. Similar thing. And I can even make put a different those characters here. So for example, here I can put just whatever things I want. For example, I have, let's say, comma, comma, this comma, and a space, space, comma, whatever I want. And then I can similar things. Let's say comma and space, space, comma, whatever. I'm just writing it. And the thing is that here, the characters here gonna be pound, comma, and sorry, pound, space, and a comma. The order doesn't matter. You can write a pound, comma, comma, a space, or space, comma, pound, whatever. So the thing is that for as long as from the beginning and the end, as long as I see any of those things inside, it will be removed. And you write it. I love Python. See it? As long as it's like this. Be careful. Don't put I here. Okay, if you put I here, it will be like Python. I will be removed as well. See it? So this is the thing. Okay, this is strip, and then we can actually do an exercise, and it's a very baby, simple example. of using all those things. So now ask a user to input a name in the format of first last, let's say John Smith. Save the first name to variable first name and last name to variable last name and print them. The printed name needs to be names need to be titled. Be careful that a user may add some spaces in the input by mistake. For example, here. For example, in the end, I have a space here, and or in the beginning, and also a user could, input some wrong format in upper lower cases. For example, I can make something like that. In most cases, people want to really pay attention to your format, right? So how can we make it? So let's write a code here. So first of all, I will have a full name, and then so I'm gonna input a full name. Input what is your full name in the, let's say, format of first, last. I ask you to input the name and then I will save the input in the full name. Then what shall we do? And because here in the format of first, last, so I need to remember what we said here is a user could include a lot of space in the beginning or at the end of the input, right? So that first thing I need to have the strip. So which is the full name, let's say strip equals to full name dot strip, full name dot strip, and then strip by what? By space. So in this way, we can just remove the spaces from the beginning and the end of the name. Now I will have what? I will need to get its first and last name, right? How to get the first and last name? We can use what? We can use split. Remember, it's as a form of first space last, and hence I just need to split it. The zeroth index must be first name. The what first index must be one, right? So I can have, for example, first name. Let me create a middle variable. Otherwise, I just one step. Let's say a middle variable called, let's say, name listed. Let's say equal to, let's say, full name strip, dot split by the space. Okay, here's the space here. Now I can have, let's say, first name equals to let's say name listed 0, and then last name equal to name listed 1. So finally I can just print the first name is first name, and the last name is last name. Okay. So put your full name. Let's say I have a long space. Let's say John. Suppose I'm drunk. I'm just Smith, whatever I want. Another spaces. Okay. Okay. Now your full name. Wait. So sorry. It should be dot strip dot title. That's the thing. Let's say John Smith space. Here we go. Wait. Title, not title. Here we go. And the first name is John, last name is Smith. Okay. I I believe in my, oh, here I forgot. Oh, no. Here I put a title here. It doesn't matter. It doesn't matter. You put where. Here's the strip, and then let me think about it here. Yes, you put a title here. So when I handle this, the name, let's say John Smith or whatever, it will already be like this way, John Smith without space. Okay, then I split it. So it right doesn't matter which where you put the title, as long as just don't forget to put it. So this is an example of using all those string variables, methods, input, print. Any questions here? No? Okay, let's continue. So next one is a conversion between string and numbers. So let me see here. Okay. So a very confusing thing for maybe beginners would be, let's say, suppose I have birth year equal to, let's say, 2000. But be careful, I'll make it to be like this way. And then I say age equal to, so this year is 2025. So if your birth year is 2000, so you should be 5 year, right? Okay. So I would, as a human, I would expect 2025 minus 2000 should be equal to 20, right? But if I print, it will show an error. It will show, hey, something's wrong, integer and a string. Indeed, you can see that if I define in this way, this tells Python that birth year is a string variable. And here, 2025 is an integer. Then use an integer to minus a string variable. It doesn't make sense. So we need to convert this string variable to be an integer. Of course, in this specific example, we say, hey, so simple, I just make it like this way, done. You are absolutely correct. However, if you're writing a big project, let's say thousands of lines, and then if the birth year is somewhat calculated or let's say written by another coder, it could be very difficult to find it. So a safer way is I don't care what is the format, I will convert, even if it's a string, I will try to convert it to be an integer number, right? How can we do? We can do it like this way, int. Int function means integer, to convert a string to be integer. And I can have, let's say, if in this case, it will be correct, you see? Or another format is float. Float means it has digits. You will see it will be 25.0. See, it tells you, hey, something. Let's say if I have now, it's May, which is like almost 6 months. Say suppose I write this, it will be 25.5. So this is the thing. So typically we have integer and a float. Okay. And the similar things, we can have some more examples. So for example, x equal to int 4.9, and then y equal to integer negative 4.9. Guess the result. First of all, negative 4.9, it's 4. Integer 4.9, it's a 4. But integer negative 4.9, it's also negative 4. Recall this operator here we had before, which is double division here, remember? It's the integer, not interval, integer division gets the integer less than or equal to this and the closest, right? Closest, sorry, how to spell closest here. Here is like a floor function. However, here int is not. It is to push the result to an integer towards 0. And hence you can see negative 4.9, if we push to an integer towards 0, it's gonna be negative 4 instead of negative 5. Okay, so here are the integer int function. And the next one gonna be something we call type. Later we will discuss something like function or class. If I'm not sure what type a number is, I can just use a type function. For example, a equal to 4.9, b equal to, let's say, integer a, let's say, and then c equal to 4.9. And I'm going to print type of a, type of b, and type of c. So you will see something like this, class float, and indeed a is a float number, class integer, b is an integer, c is a string. You may have a question, hey, what does class mean? Why not it's just called float, integer, or string? This is later we will introduce class in this lecture too. So in Python, each object is considered as a class. So this just tells you, it's a class. It belongs to, let's say, a belongs to a class called float, b belongs to a class called integer, c is a class called string. So this is the meaning. Later we'll see more about the type function here. Okay. So these are something about the conversions between string number and also type functions. Any questions? No? Okay, I see the time's already 7:04. I mean, in other words, the CDT is 8:04. Let me finish this slide, exercise 2.2, and then we will finish today's class. Okay, so I will have, let's say here, let me just try to mark down. I know I didn't try to mark, let's say exercise 2.2, run it. Okay, looks beautiful. Here, it's going to be a variable, be a code. Okay, let's read it. It's a conversion between Fahrenheit and the Celsius. And the formulas here, Fahrenheit, Celsius equal to Fahrenheit minus 32 divided by 1.2. So I'm going to ask you to input the temperature in Fahrenheit and then print the corresponding Celsius. Let's see how they do it. So first of all, I want you to input something, right? So I have the Fahrenheit equal to input, how to spell? Fahrenheit, okay. I don't know how to spell this. Input a Fahrenheit degree. This is F. And then I'm going to have C equals to F minus 32 divided by 1.8. 1.8, no 1.9. And then print this Fahrenheit equals to C Celsius. Celsius is wrong. How do you spell Celsius? Just because I did this seriously. Okay. So I'm afraid this will be wrong. Pay attention. This code will be wrong. You know why? Because here, let me first run it. Let's say I want a 30. It should show yes, error. Because remember, your F is what? Your F is a string. For example, I can just print type of F. Whatever. It should first show me the type of, let me just, so here's the default. You see, for example, suppose I don't know why this code is wrong. I'm gonna just make this, a line to be common, to comment it. Now I just have a look at this. And this will still be wrong because the mistake is this step. Let me just have a look at this. So now let's say 30. Type of F is class string. In other words, F is a string variable. However, if I write this way, again, it's going to be the same mistake as here, which is 2025 minus birthday, which is string variable. How can you do the minus, right? Similar things. F as a string variable and you use F minus 32. No, it doesn't make sense. What you should do is what? To make this float F. Don't use integer, okay? Because I could give you a float number, which is for 30.4. I will make it to be float F, convert this string variable to be float first, and then do it. Then it should be correct. I can just remove this one now. Now I can just delete it. Let's say 30.5. Okay, so here 30.5 Fahrenheit equals to negative 83. Negative 0.83 Celsius. And then we can run it again. Let's say today, suppose it's 70 Celsius equal to what? Okay, sorry, 70 Fahrenheit equals to 21.111 Celsius. Okay, so yeah, I believe this is everything about today's class. Thank you very much. And then I will stop sharing. And before I leave, I just want to make sure I'm recording everything correctly. Then let me see. Okay, I see Dr. Carichius already left. Let me just end the class, and I hope it's recording. Yes, I can see it's still recording. So I will end the class, and it should automatically save the document, to my local desktop. And then again, I will upload in this under this list. You can see it from the syllabus here. I will upload the video here, recorded video. Okay. Thank you very much, and see you on Thursday.